the opportunity to speak here, and thank you for being here. So my talk is about the middleware services and training services for implementing fair data principles. And you see me presenting, but oh, there you go. But I'm actually presenting the work of this fair data software engineering team, and much of it has been prototyped by this fair skunk team, and we do a lot in collaboration. So it's about fair services, so fair, findable, accessible, interoperable, and reusable, and very importantly for humans and computers. You've heard that before. And to share a little bit of introduce the vision a little bit, I have this video.
The explosive rate of data production is changing science in fundamental ways. The vast amounts of scientific data being produced today can no longer be effectively interpreted, communicated and shared through papers. Without proper stewardship of data, potential scientific progress is more and more impeded by fragmented patches of information that cannot talk to each other. The tremendous growth in information is therefore not effectively translating into an increase in knowledge. To harness the power of big and complex data, people and machines need to work together. To make this happen, the revolution in data production needs a revolution in data stewardship. Good data stewardship follows fair guidelines and will enable an internet of data and services, helping data and algorithms to find each other, talk to each other, and remain available for reuse.
Okay, so that gives you a bit of an introduction to the vision. And this vision is shared by quite a lot of people and organizations. So here's Elixir and BBMRI and the European Open Science Cloud, NIH Commons, and more recently also the G20 are sharing this vision. But the vision you also need to implement, and that's what the fair services are for. So they're really principles, and the fair service you also have to make some implementation choices. You will see that here. So these are the services that this team I was talking about are creating. A verifier to make fair data point, a find service, and something to annotate. And I will focus on these three. Those will be in the presentation. And as you saw on the previous slide, these are a implementation of fair services. So there can be different implementations. A central piece, a key piece, is the fair data point, which combines a lot of what the fair implementation is about. And in the presentation, I will first focus, in the first part, there's a video that is focusing on the find and access part of this service. And the latter part is about the content of what you have access to, so making data linkable itself. So the fair data point, it uses a catalog vocabulary to allow you to go stepwise to the data. And this also gives a sense of control that, for instance, in my rare disease community where I'm from, is very much appreciated. And you will see this in the video, this going stepwise, everything through your eyes. So what you will see, you see the implementation choices we made here, REST-based, and this data catalog vocabulary. And you will see a demonstrator application, in this case based on a rare disease case, answering questions across multiple resources. You get a look under the hood, the fair data point. Rajaram will actually speak to you. Going through the fair data point, you'll see that he's searching and adding a fair data point to actually get more out of this demonstrator.
In this video, I would like to demonstrate a web application which we built on top of fair data point. This is a web application which we built for rare disease researchers. This application combines data from different biobanks and patient registry and answer some of the commonly asked questions in rare disease world. Here you see the architecture of this web application. On the top you see a web client which is connected to a backend. In our case is connected to a linked data store. The content of this linked data stores are coming from different biobank and patient registry fair data point. This is a web application. Here in the top you see a list of predefined queries. When you click one of this query, you get a form to fill in. So in the query which I clicked, I'm looking for like number of biosample from Madonna with particular phenotype. So the query require phenotype as an input. So if you select like a different query, then you get like a different form to fill in. I already preloaded this demonstrator with some data. So I would like to answer this query, like where I would like to get a number of biosamples from Madonna with particular phenotype. So I'm going to select like a white mouth as a phenotype, and when I click process, I get a result table here where my demonstrator suggests like it finds like 6 biosamples from this particular biobank. By the way, all this blue text are like clickable links. So if I click like the biobank link, I get some information about a biobank, which is a tool like in a rare disease world which collect information about different biobanks and patient registries related to rare diseases. So when I click the phenotype link, I get like a redirect URL which points me to like white mouth concept from human phenotype ontology, where you get like more information about white mouth concept. And this particular ontology also has like a nice hierarchy. Let's see like what happened like if I select like one of this upper concept as an input for my query. When I do it, I get a result table where you see like a number of different phenotypes related to head and neck or reporter. So I see like wide mouth is reporter, also see like abnormality of teeth as reporter in my result. And here like you also see like you get like results only related to one particular disease. So in order to look for like data sets that are published in a fair data point, you can use this tool called like fair data search, which simply indexes like metadata from different fair data points, and the user can search for like data sets that they are interested in. So I'm interested in like ring 14 database. So when I search, when I enter it in a search box, I get a result. So in this particular fair data point, the ring 14 clinical data set is described. So this is the landing page of that particular fair data point. So where you get like some metadata information about that particular fair data point, and this fair data point contains 2 catalogs. When I click one of those catalog, I get like more information about that catalog. So I get like you can see like it's a catalog about disease registry, and this particular catalog contains like 2 data sets. When I click one of those data set, and I get like more information about that data set. So in this case, like I get information about like a ring 14 clinical database, and this particular data set is distributed in 2 formats, as a HTML page and like as a turtle format. When I click one of that, then I get like more information about that particular distribution, and this is a turtle distribution, and we can download like the content of this database via this link. So when I provide like this as a input to demonstrator, so I'm basically asking demonstrator to index like all the metadata information from this particular fair data point, and also if some of the data sets is distributed in a turtle format, I'm also instructing my demonstrator to index those turtle files too. So I provided a link, I gave a name for this particular fair data point, and when I hit like a cache button, all the metadata information are indexed now. So when I go back and execute like the first query again, so when I select like abnormality of head and neck as an input and process it, now I get like more results, and now I get like results which are really reported for like ring 14 disease as well.
So as you can imagine, in the rare disease community, we're trying now to, one by one, make more fair data points. And just to show how generic this middleware is, because that's what the team is focusing on, this is the same demonstrator, just a screenshot where it's used for plant questions and based on plant data. So as I mentioned, this is the picture of the fair data point. We've now done the data access part, as I call it. In the second part, we'll show how the content gets there, the linkable data. And this is also what we use in training sessions and things like bring your own data workshops. So what you'll see here is the verifier that is based on OpenRefine and with the RDF plugin. The implementation choice for interoperability here is linked data and ontologies. What you will see is therefore that Rajam has made a semantic model, sort of sketch model for this specific application. He will add one relation, just as an example, one relation from that model using BioPortal and the verifier, create the interoperable data set, it's RDF, and Rajam sometimes mentions Turtle, that's a form of RDF, and then upload that linkable data to the fair data point. Oh. Well,
Before I start with the verification process, I like to draw your attention to the model which I'm going to use in the verification process. So you start your verification process by clicking on like create project button. So I'm going to use like a dummy dataset from Ring 14 patient registry. Select the file and click OK and click next. This is a default view of verifier. So when I go back to my model now, so this is a triple that I would like to initialize first. So I'm going to create like a URL for each patient, and I'm going to assign like a type definition for that URL. So according to my model, the type definition is coming from SNOMED City ontology. So you can use like existing ontology repositories like BioPortal to search for ontological URL. So I'm going to search for like patient in BioPortal, and BioPortal will suggest me like a list of ontology which contain patient concept. But according to my model, I'm supposed to use like a patient URL from SNOMED City. So this is a type definition URL that I'm going to use for my triple. So when I go back to verifier, so in order to create like triples from your dataset, you can use like RDF plugin in the verifier. So click on the RDF button, select like edit semantic model button. Now what you see here is like a subject configuration option, and you can add property to the subject. You can configure your subject URL by clicking on row index button here. I want to use URL with patient ID as a suffix of my URL. So I'm going to choose like patient ID, and this is of type URL. Verify your final URL by clicking on preview/edit button. So this is how my final URL looks like. It starts with prefix mydomain.com/resource and ends with suffix, which is like a patient ID. Click OK and click save. So here, like the RDF preview session, you can see preview of the RDF what you created. I just initiated like a subject URL. I didn't add like any properties to the subject URL. So I would like to add property called like RDF type. You can do it by clicking on like add property button. Then you get like a property configuration options where I'm going to search for like a RDF type. I have to assign like an object for this predicate. In my case, I'm going to use this URL. So I copy this URL, go back to verifier, and I say like I'm going to provide like a constant value, because this URL is going to stay for all the patient ID in my dataset. So I'm going to paste the SNOMED City patient URL, and I'm going to say this is of type URL, and click OK to close this button and save your configuration. And you can preview it by clicking on RDF preview section. Now you can see I initiated like a subject URL which is of type SNOMED City patient URL, and I'm going to repeat the triple initialization step for all the triples described in this picture. And this is how edit RDF schema alignment window looks like if you initialize all the triples according to this model description. So once you finish with editing the RDF schema, post this RDF file directly to fair data point. So you can do it by clicking on like export button and select post to fair data point option. So here like you'll be asked to provide like a fair data point URL. For this demonstration, I'm going to post the file to this particular fair data point. So this particular fair data point contains like one catalog. So I'm going to post it to this particular catalog. So here like you provide like a base URL of your fair data point and select apply, and you get to choose like a catalog from this fair data point. In this case, I'm going to post it to test catalog. I'm going to add a data set. Let's name it as a test data set. And this is version 1. And I need to provide like a publisher URL. So in this case, I'm the publisher. So I'm going to use my ArcID URL. And add publisher name. I'm going to add my name. I'm just going to make up some theme here. Click save. Now I'm going to add like some metadata information about this particular distribution which is pushed to Virtuoso. So again I'm going to name it as a test distribution, open license, and this version 1.4, and click save. When I click OK, the metadata and data will be pushed to fair data point. So I can verify it by going back to the fair data point. And I'm going to look into the catalog. So this catalog now contains like one data set. When you click on the dataset link, you get like metadata information about the dataset which we posted using Verifier. And this particular dataset contains one distribution which points to a Virtuoso instance to which like a fair data point is connected to. And this is our RDF file that we created in the verification process.
So typically in training sessions we do this with multiple data sets and then we start nicely querying it. Okay, so this is the fair data point. Now it's all complete. So we have done the access part and also we've done now the semantic part, the inside of the fair data point, for which we want to share these models, for instance, on fairsharing.org. So in conclusion, we've seen these three services. I should stress again, it's middleware. It's services on which you build other things like the demonstrator, but possibly also workflows. We have Galaxy going on, so in theory we could do this in Galaxy. The Verifier, the second part, is a basis for data linkage workshops, training, and for prototyping verification. On the right side here you see an adopt part that I added because we're also working with software developers to actually make those software, for instance registry software, make that fair data producing software that will lower the burden of especially the second part. For developers there's some pointers here. So there's a wiki, there's a GitHub link, and upcoming is architecture for rare disease software providers that we're working on. And we very much welcome people to contribute to the team or tell us what you're doing. Other types of services, fair data stewards, people who can actually help go through this process. Training material, the contact person is Eric Schultes in our team. We have a biannual course. If you're interested in doing this or learning how this is done, you can check there. And we also have advice for managers, like fair project blueprints and organizational support. And that's where I end by looking at the people who actually done the work here. And yeah, right on again.
Well, we are just in time, so I suggest the questions are only for the coffee break. So we now have the second talk by Anton. Just Anton, by Just Anton,
Yeah.
from Pennsylvania State University and Galaxy.